We talked about the idea of children changing the behavior of their parents, modifying the behavior of their parents. That formal concept is called polymorphism. Now, polymorphism is a Greek word, poly, many, morphism is forms, many forms. And polymorphism allows a base behavior, like we talked about generating electricity earlier, to be changed based off of the specifics of the child class. So, most pretty much electricity is always generated by rotating something very, very fast and creating some magnetics around that or whatnot. But there are other ways. So, that's not what solar cells do, for example. All right, so polymorphism is really child-specified behavior. So if you think of a salad bar gives you all these great options for how to create your meal or a feature of your meal being a salad. But it's up to each individual to kind of assemble those things into their own behavior. Now, again, that's not always true. This is an analogy, so don't take it too far. In some cases, the parent class defines most of the behavior and the child just customizes it. So the parent class walks in with a whole meal and says, well, what do you want on your salad? Think of it that way. But the point is that the the goal of inheritance hierarchies is to have some flexibility in the behavior of code as it goes forward. So if I think about, for example, the animal kingdom, if I have a bunch of random animals sitting around, I could organize those animals into a hierarchy, a grouping of groupings. And in this case, notice I have many levels of classes. So if you're doing UML, one thing to note is that if I see a word that's in italics, like animal, vertebrate, invertebrate, carnivore here, that's an indicator of an abstract class. I can also just tag it saying it's abstract. You've seen tags maybe with the less than, greater than percent with a word in between. I can say it's abstract, or I can just put it in italics. So if I see a word in italics, it's an abstract class, or if I see a method in italics, it's an abstract method. So in this case, I can have an animal, which is an abstract class, and I have two different types of animals, vertebrates and invertebrates. And then I also have a subtype of vertebrates called carnivores. And I know there's carnivores of all different kinds, so don't get too picky with this. But we can see there's a bunch of different types of animals that fall into this hierarchy. One thing we can say is all animals speak in some way. They have some sort of communication. Now, it might be a verbal thing, might say something out loud. Maybe it's a chemical thing that they emit some chemicals or whatnot. But even grass, when you have that smell of grass, it's kind of a pheromone that it puts out to say, hey, I'm in distress here. Now, okay, so maybe there's some animals that don't speak technically, but for our hierarchy, it's good enough for the ones we're putting out here. What does the lobster say? Um, so I can put this placeholder up top. It can be abstract or not, this behavior up there. It doesn't have to be. But I definitely want to be able to change that behavior for each different animal. The pig says oink in this case. The tiger says roar. The sheep says ba. The cow says moo. Something you learned probably a very long time ago, right? Well, now we can apply that into our inheritance hierarchy by replacing the code that the higher up class, in this case the animal class, defined for us. So that layered functionality means we can do that with any method we want to. So another thing all animals do is eat. We absolutely know that. And we can define behaviors at each level. So we can say, well, vertebrates in general, they eat plants. They're going to munch on some plants. That's going to be what they eat. But we also can define specific behaviors. So like pigs, they eat a lot of plants, but they'll eat anything. Pigs will eat pretty much whatever you put in front of them. And carnivores in general don't eat plants, they munch on animals. Now, they'll eat some. If you've ever had a dog or a cat, mine love to go out and munch grass. But they also mostly eat, meat, other animals. So the point is I can define behavior at any point in the hierarchy. And then I can what's called override that behavior. Which is called polymorphism. So you'll see it in most languages called overriding behavior, changing it there, but the concept behind that is called polymorphism. The important runtime understanding, though, is that the object type is what determines the method call. So if I have an object that is a pig, no matter what variable it's stored underneath, a pig could be a vertebrate, it could be an animal, I don't know if I would call a pig a carnivore, but whatever variable it's stored under, the behavior is determined by the object. So anytime a pig object gets told to eat, it eats, munches on everything around. Where if a tiger gets told to eat, it always obviously munches on animals. If a sheep gets told to eat, well, we didn't define a behavior for a sheep. Sheep didn't have a eat method, but it inherits the behavior from the invertebrate. So it munches on plants. And then the if I go create an animal object and tell it to eat, well, there's two problems there. First of all, I didn't define eat as a behavior the animal knows about. Eat is an abstract method, and more so, animal is an abstract class, so I can't even create an animal instance to begin with. So don't forget, abstract classes, I cannot have an object of that's called an animal. I can have a variable that's called an animal, and the variable that's called an animal could be a pig or a tiger or a sheep, which then do their own behavior when they're told to eat, but the animal class itself doesn't. So the point of polymorphism is to allow you to specialize behavior to that specific object, to that specific class, and its attributes and its behaviors that it wants to model. So polymorphism is absolutely required when methods are abstract. If I have an abstract method, I have to give it a definition to not be an abstract class myself. I'm allowed to ignore stuff, but I also have to be abstract. So again, invertebrates didn't define eat. That just means that every invertebrate has to define how it eats for itself, where we're saying the default for most mammals is to eat plants. The great thing about polymorphism is it allows for entirely unique behaviors. I can completely replace my parent's behavior. That's the default of polymorphism. When I overwrite it, the parent's behavior entirely goes away, but I can still typically access that behavior by calling the parent's behavior, which is typically called a super call. Calling my super class and getting its behavior. I basically call that method from my class with something like the word super in front of it, depending on the programming language, but that's what you do in Java. And then that will give me that behavior. It will let me access what my parent would typically do. So again, a carnivore can still eat plants, but its default is to eat meat. So ideally, the child class does not change the contract. So when I call eat on an animal, it doesn't poop. Now that's a different call. Every animal poops, it poops its own way. But it still does something that resembles eating, adding nutrients inside of that. It's not a requirement, but it makes life easier that everything follows the same intent of that. It's not like, okay, well, if I call eat on elephants, they also poop at the same time. It might be true in the real world, but I don't want that to be the case because then I have to call eat to get an elephant to poop, and then I might not have food, crazy scenarios like that. So it's best not to do random things in polymorphism, but certainly feel free to use this capability to customize the behavior of children as it goes and really make your model align to the real world behaviors that you want to try and mimic.